Far beyond the orbit of Mars, sunlight is little more than a whisper. Out there, everything should sleep, frozen, silent, timeless. And yet a faint shimmer moves through the dark. 3IATLAS, an interstellar visitor that should be dormant, but isn't. Telescopes catch something impossible. Water vapor 40 kilograms every second, rising from a body 3.5 astronomical units from the sun. It's as if the comet itself is breathing, exhaling in the cold where water should never flow. Astronomers stare at the data in disbelief. At that distance, ice is stone. Nothing melts. Nothing moves. But 3IATLAS ignores the rules. Its coma glows green with cyanide and nickel. Its spectrum heavy with carbon dioxide and chemical whispers that defy simulation. One researcher said quietly, "It's acting alive. Maybe not in the biological sense, but in motion." In defiance, it almost is. The first hints came from NASA's SWIFT telescope, an ultraviolet sentinel meant to catch gamma-ray bursts, not misbehaving comets. Yet in January 2025, SWIFT's detectors filled with the signature of hydroxyl, the broken echo of water torn apart by sunlight. At that distance, our own comets sleep until they're close to Earth's orbit. 3IATLAS didn't wait. It released water, cyanide, carbon dioxide, even traces of nickel, a metal that needs far more heat to move. Each detection shredded a page of the rulebook. Compared with past interstellar visitors, it's the strangest yet. Oumuamua was dry, a silent rock slipping past. Borisov behaved normally, shedding gas like a textbook comet. But Atlas sings a different song. It's the only one that behaves as if it remembers another physics, written under another star. Every comet we've studied follows a pattern. When metals begin to sublimate, iron and nickel appear together, inseparable companions forged in the same stellar fire. This time only nickel glowed. At the European Southern Observatory's Very Large Telescope, the spectrum came back clean. Nickel blazing, iron absent. No known process in our system separates them so completely. Scientists offered possibilities. Perhaps nickel rode with carbon compounds that vaporize early, while iron stayed locked in silicates. Maybe radiation over billions of years sculpted a thin, nickel-rich skin. Or perhaps this object was born in an ancient system, where the chemistry of metals was simply different, whatever the cause. One thing is clear. 3IATLAS carries a memory older than the sun. Its metals tell a story our models never learned to read. Most comets brighten smoothly as they near the sun. More light means more heat. More gas, predictable curves on a graph. But Atlas doesn't brighten, it awakens. At first, the coma is dull and gray. Then without warning, it flashes vivid green. Cyanide emissions rise. Nickel intensifies. Its water output multiplies faster than geometry can explain. Astronomers call this switch-on behavior, a chemical threshold suddenly crossed. Maybe fractures expose deeper layers. Maybe drifting ice grains warm separately, each becoming a new source of gas. Whatever the trigger, Atlas behaves as if it contains several hearts, each one beating at a different temperature, each waiting for its turn to come alive. Trace its path backward, and 3IATLAS leads us out of the comfort of the solar system and deep into the Milky Way's thick disk, a realm of older, slower stars born when the galaxy was still forming its bones. If those calculations hold true, this wanderer could be 7 billion years old, twice the age of Earth, older than our sun's first spark. Imagine that. When this object froze into being, our planet didn't exist. No oceans, no continents, no life to name it. Just clouds of hydrogen swirling around a newborn star somewhere far away. Under a spectrum we may never see, its chemistry carries the accent of that forgotten era. A universe with fewer metals, more carbon, more oxygen. Back then, heavy elements like iron and silicon were rare. They hadn't yet been cooked inside generations of exploding stars. So a body born there would contain less iron and more volatile ices, ingredients that evaporate easily even in weak sunlight. That might explain why Atlas behaves as if it's made of air rather than stone, why it exhales when it should stay frozen. When astronomers plotted its orbit through the galaxy, it didn't trace back to any known cluster or stream of stars. It comes from nowhere in particular. A loner ejected from a system whose parent star may already have died. Perhaps a giant planet's gravity flung it out. Perhaps a close stellar pass ripped it loose, sending it on an endless voyage between suns. For billions of years, it drifted through the interstellar dark, silent, untouched, colder than any laboratory on Earth. No collisions, no friction, no erosion. Only cosmic rays carving microscopic scars across its surface. And then by pure chance, its trajectory intersected ours. A green speck from another age passing through our sky like a whisper from prehistory. One astronomer described it beautifully. It's as if the galaxy tossed us a message in a bottle, and we happened to be standing on the right shore to find it. Every spectrum we record from Atlas reads like a language we half understand. In our comets, water vapor dominates, the unmistakable fingerprint of the icy worlds that formed beyond Neptune. Carbon dioxide is secondary, a faint punctuation mark. But in 3IATLAS, the hierarchy is reversed. The measurements show that up to 95% of its outgassing is CO2, with water barely detectable behind it. It's as though this comet was built in a warmer nursery, close enough to its original star that water could not freeze, but carbon dioxide could. A chemistry flipped upside down by a different sun. Then comes the cyanide, the green ghost in its coma. On normal comets, cyanide appears early, released with the first jets of water. Here it waited, hidden, emerging only after the main water plume had already peaked. Something about Atlas keeps its poisons locked away until later, like a sequence only it knows. And the nickel, the stubborn, gleaming mystery. Nickel atoms glowing bright while iron stays dark. It shouldn't happen, yet it does. Some scientists suspect complex organometallic compounds, molecules where nickel bonds with carbon monoxide, forming volatile shells that evaporate easily. Others think radiation weathering sculpted a thin skin of nickel over eons, leaving iron buried below. Whatever the mechanism, the result is a chemical accent unseen anywhere near our sun. Each ratio, each spectral line, is a clue from another world. And yet, for all its alien chemistry, nothing here screams artificial. There are no impossible isotopes, no engineered elements, just a different outcome of the same cosmic recipe. The galaxy writes in many dialects. Atlas simply speaks one we're hearing for the first time. Still, that difference matters. Because if this is what an ordinary comet looks like somewhere else, then our normal might be the exception. Perhaps Earth, our sun, our entire neighborhood, the water-rich iron-heavy type, is the outlier. And the universe, vast and ancient, is filled instead with carbon-rich worlds breathing CO2 rather than water. That thought changes everything. It hints that life's ingredients might form under far broader conditions than we assumed. If chemistry can rearrange itself this freely, then so can biology. We live in a golden age of confusion. Every year, telescopes flood us with terabytes of sky, and among those pixels hide things that shouldn't exist. Fast radio bursts, flashes lasting milliseconds, brighter than galaxies. Odd radio circles, ghostly rings of energy no one predicted. Planets orbiting white dwarfs, stars dimming for no reason, comets that act alive. It's as if the cosmos decided to throw the syllabus away and improvise. Most anomalies eventually bow to logic. New calibration, a missed variable, dust behaving oddly, and order returns. But occasionally one refuses to fit. 3IATLAS is one of those rare stubborn mysteries, because it's not one anomaly. It's several layered together. Ancient origin, inverted chemistry, missing iron, water where there should be none. Each on its own could be explained away. Together they form a pattern too tangled to ignore. Scientists don't call that proof of anything supernatural. They call it an invitation, a sign that their equations need more room to breathe. Every failed prediction is progress in disguise. You learn more from what breaks the model than from what confirms it. And maybe that's why Atlas feels so electric. It arrived precisely when astronomy had grown comfortable, when our software could predict almost every comet's behavior. Then came this traveler from another system, quietly tearing through those expectations. For weeks, observatories chased it across the sky. Spectrographs hummed. Data piled up. Each new reading left scientists murmuring the same words. This shouldn't be happening. But in science, that's the best phrase you can hear, because shouldn't be happening is where discovery begins. So now, 3IATLAS stands beside a growing family of cosmic rebels. Oumuamua, with its silent acceleration, Borisov with its perfect textbook trail, and this new visitor that behaves like neither. 3 points on a map that hint at a larger landscape, a galaxy teeming with wanderers carrying chemistry we've never imagined. Perhaps, years from now, we'll look back on this age and realize it was our renaissance, the moment we stopped pretending the universe had to match our expectations. So what is it really? A comet, a relic, a messenger from an older sky? It isn't alive, not in the biological sense. But in motion, in reaction, in the way it breathes, it feels alive. It flares when touched by light, hides when cold, shifts colors like a pulse seen through glass. It responds to the sun as if remembering warmth for the first time in ages. And that illusion of life touches something ancient in us. Because we too are born from dust that once orbited other stars. We recognize the patterns, even when they're carved in ice instead of flesh. The simplest answer remains the truest. 3IATLAS is a natural comet, sculpted by a physics we barely grasp, weathered by radiation, etched by time and awakened by sunlight. Yet within that simplicity lies wonder. It broke our equations not by being magical, but by being real in ways we hadn't predicted. It proved that even familiar laws can produce unfamiliar beauty. Maybe that's its true message, that the universe still keeps secrets, that even after centuries of observation, we are only scratching the surface. Think about it. Every assumption we hold about comets, where they form, how they die, how they shine, comes from a single planetary neighborhood. One thin slice of the galaxy. Now imagine a million other neighborhoods, each with its own chemistry, its own definition of normal. Atlas is the first whisper of that diversity. Somewhere out there drift other travelers, fragments from forgotten systems, each carrying the story of a star long extinguished. When sunlight finds them, they will ignite, and for a brief moment the universe will speak again. That's why astronomers keep watching, even when the answers are unsatisfying. Because mystery isn't failure, it's the fuel of discovery. To look up and not understand is not defeat, and it's the point. And tonight, as 3IATLAS drifts beyond the inner system, its green glow fading into the black, we realize the truth. The cosmos doesn't owe us explanations. It only offers invitations, challenges to keep wondering. We listen, we measure, we learn. And in that act of curiosity, that refusal to stop asking, we become the very thing we seek, alive. So let the comet go. Let it fade into interstellar night, carrying the signature of ancient suns. Some future civilization may catch it again, study it, rename it, and feel the same wonder we feel now. Because wonder doesn't belong to one moment or one species. It's the thread that binds every mind that ever looked up. And if you step outside tonight, past the city lights and find that faint emerald haze near the horizon, remember, you are seeing not just a comet, but a memory of the galaxy itself, a frozen echo from before our world began, breathing once more beneath our sun, once more beneath our sun.